And we'll talk about how these are often represented. So, for example, an observation is often represented with the notation x. X means some variable, right? And this variable could be, for example, height. It could be weight. It just stands in for any variable. Once you know the variable, you could just as well write the word weight. I don't care. But x stands in for a variable in general. Now, I often use notation x sub I. And the reason I do this is because now this tells me that the variable has been measured. And the variable score, right, this is a score, belongs to a particular individual, I. So like this subscript in statistics is kind of like a name tag. It tells you to whom a value belongs, right? So x sub I, it is the variable measured in some particular unit of analysis, right? So an observation or score belonging to a unit of analysis I, right? So for example, if I talk about my height, I could just as easily say the height of Charles, right? And I'm not going to write it out because this doesn't work very well for writing. But, you know, that could be my measurement. And that then would have a specific numeric value, for example, 70 inches or 178 centimeters. So once I know specifically what the x sub I is, i.e. what variable am I measuring and what unit of analysis, then I know what the actual value for it is, right? Statistics are annotated normally with some additional operator. So statistical notation for a mean is x bar. That's how you read this. It's x with a bar over it. I'll show you how to type this in Word later. In APA notation, they often just use capital M to represent a sample mean, but this is statistical notation, and we'll use this most often. So this is a sample statistic, x bar. Now, a sample has a certain number of people in it, and the number of people we often represent with n. N is the number of people in a sample. The number of people in the population is often characterized with a capital N. So there's a difference there between little and big N. So notice capitalization matters as well as things like a bar or no bar. And a parameter, for example, also has its own notation. So the parameter of the mean in a population is represented with a notation Greek letter mu. This is my attempt at mu. It's kind of like a curly, M, kind of like a U. I can show you the symbols in a program here later. Here, let me pull it up and we'll show you on Word real fast. So these are notation that you'll see. You'll also see things like sigma, which has different meanings depending on whether it's capitalized. And sigma is a Greek letter. So let's just look at some of these real fast here in word notation. All right, so I have enabled what's called math language. So math language allows you to do things like this. So instead of inserting a symbol, I can use a slash and then type out what I want, and it'll turn it into the symbol. So that is mu, right? And I did that simply with slash mu, which is how you spell mu, and it turns it into the symbol. So instead of having to go to insert and then go to symbol and then try to find my symbol in all the symbols, so I'm like, okay, my symbol, where's it going to be? I need Greek. Okay, Greek and Coptic. And then where is mu? Oh man, where is this mu? You probably have already seen it, right? I'm still looking for it. Where's mu? There's mu. Oh, I found it. Look, Greek small letter mu, mu, right? Insert. And so now I put the symbol in. Notice that was much more painful. So the way you can enable math language to do symbols is in Word, go to Options. Under Options, go to Proofing. Under Proofing, go to Autocorrect. In here, go to Math Autocorrect. And then check this box. It's checked on mine because I already did it, but you probably don't. Use math autocorrect rules outside of math regions. And then notice here it gives you the whole list of all the math autocorrects, so all the slashes that you can then turn into things. So you could do degree symbol really fast, degree Fahrenheit really fast, degree Celsius, right? Super fun, super cool, great for math and stats. So there you go. So we've got things like X bar, right? Hey, look, there it is. I made X bar. So all I did was X slash bar, right? So we talked about like X and sub I is a unit of analysis score, a UA score, right? An X bar is a sample mean, right? A mu is a population mean, right? We talked about the fact that N is sample size, and n is population size. You also have operators. So operators are like this, capital sigma. This is the summation operator. So what it means is whatever follows, add it all together. So if I had something like sigma xi, what that means is add all of the scores for each unit of analysis. So if I have 50 people in my sample, I'd add all 50 of their scores, right? So then if I had x sub I, and then I did that divided by n, that would be how I compute my sample mean, right? So that's the computation. That's how I'd write out a computation for my sample mean. It is the sum of the scores divided by the sample size, right? So that would be notation for simply calculate a mean, right? So this is why knowing notation is important, because if I gave you something like that, you need to know that simply is telling you to get the mean, add all the scores and divide them by the number, right? So don't get caught just because you see a symbol. Don't be like, oh, right? Look in your book, look back at these resources, make sure you know what the symbols mean. Learn the language, right? Don't get stuck on that. Don't like brain fart simply because it's a Greek letter, right? So there's some basic notation. We'll develop more as we go, but these notations are kind of some of the ones that are introduced early in your book. And now you know how you can generate them quickly and easily using Word. So there you go, class. That's our first day. So it's better than having to sit in class for 3 hours, right? It's still kind of a long one. Like I said, I'll explore doing some different types of recording, long and short, to see kind of what feels better. But feel free to take it in chunks if if I have more long ones. You don't have to sit and watch the whole hour. Watch 10 minutes about one topic, come back, watch the next 10. If you made it through this whole one from start to finish, good for you. If you took breaks, good for you. But guess what? You made it through lecture 1.